This is Geometry Lesson 8-4, Multi-Step Trigonometry. So, one of the reviews that we have today is to find the area of a triangle. Bear with me, I know that you already know this, but in order to find the area of a triangle, you need to first have the base. So this length right here is the base. And remember that you need both this segment and this segment. So for example, in example number 2, where it says to find the area, it tells us that this length right here is 30, but we don't know this length right here. So you need to find the remaining part of the base. The next thing that we need is the height. This height right here of the triangle, it'll always be a 90-degree angle with the base. And the formula for that is going to be base times height divided by 2. If you're ever curious on why that's the formula, please ask me that question because it's a fun little answer. So a lot of students will ask, how do I know where to start for the problem? Because there's a lot of different things I could do. I could think of this as one giant triangle. I could think of the left triangle over here. I could think of the right triangle right here. Where should I begin? And my advice to you is look for 2 numbers and 1 variable. That will tell you where to go. Because in general, you'll have some sort of trig function. I'm going to randomly select sine. Sine of an angle is equal to the opposite over the hypotenuse. One of these 3 things you need to be able to solve. Typically speaking, it's probably going to be the opposite or the hypotenuse. You'll usually always know the angle for this lesson. So one of those things should be a variable. Let's try one. So there's really 2 types of problems that I'm going to be assigning on the quiz, test, and homework. And one of those is solving for x, and the other one is finding the area, which is a more convoluted way of asking you to find 2 things instead of 1 thing. In this example, I'm only finding 1 length of x. In the case where I'm finding the area, you need to find this length to find the base and this length to find the height. All right, so to solve for x, first I'm looking for 2 numbers. And you say, okay, well, there's a number and there's a number. This is not a constant, it's a variable. I only have 1 constant. So this triangle on the right side is not a good place to start. This triangle on the left side is a perfect place to start because I have 2 constants. The question is, where should the variable go? Should the variable go on the base or should the variable go for the height? We don't need the we don't need the base for this problem. We're not trying to find the area. We really need to find this height here because it is a shared side length. If I find this side length, I will have a number, another number, and a variable. That's what I'm looking for. So I'm going to assign this some sort of variable. I'm going to randomly select y, and I'm going to set up my trig function. So I'm going to make sure that I do a good job teaching here and say, okay, so this is the triangle that I'm analyzing. It has a 90-degree angle there. There's a 20-degree angle here. And I have a length of 8, and I'm going to call this length y, and I'm going to set up a trig function. I'm noting that on the opposite side of this triangle is my opposite. This is my hypotenuse. What trig function relates the opposite hypotenuse in the angle of reference? Well, the O sound of the SOHCAHTOA. So this is going to be sine of my angle of 20 degrees, and that's going to be equal to my opposite over my hypotenuse, my y over my 8. And then from here, you can solve. And remember that our trick here is to take our 8 and move it up to the diagonal to get y by itself. So our y value really in this case is going to be 8 times sine of 20 degrees. So what is that approximately? And I'm realizing I'm running out of room a little bit, so I'm going to move everything up just a tad. I'm going to grab all of that, move it. Oh, I didn't want to grab the picture though. Here, can I deselect images? So deselect images. There we go. So if I grab all of that and move it up just a tad, then I can say y here is approximately, and I need to split my screen, pull up my scientific calculator, like it on the left, and I'm going to type in 8 sine of 20 degrees. And I'm rounding to the nearest 1 decimal place for this entire lesson, just like I will on the homework and the quiz and the test. It's going to be about 2.7-ish. Okay, so now I have the length 2.7. I can fill that in up here. Instead of having a y, I can say, okay, well, this y, that's a big eraser, is 2.7. And now I can look at this triangle on the right side. So let's go ahead and redraw that triangle on the right side. Calculator, I'm going to put you away for just a little bit. So this triangle on the right side looks like this. I have a length of 2.7. I have an angle of, let me make sure I have enough room here, 58 degrees. And I have this length of x. Notice again, I have 2 constants or 2 numbers and 1 variable. That means I'm ready to solve. So I need to label everything. I have the opposite angle. Again, it's opposite of my angle of reference. And then opposite of the 90 degrees is my hypotenuse. Therefore, this is the adjacent. So what makes the OA sound? In SOHCAHTOA, TOA makes a TOA sound. So I'm going to say tangent. Tangent of my angle of 58 degrees is going to be equal to the opposite over the adjacent, 2.7 over my adjacent, which is x. And from here, I'm going to solve. Remember that our trick, we can freely exchange these diagonals. I can switch my x and switch my tangent to 58. So my new equation becomes x in the top left, 2.7 hasn't moved anywhere, it's still in the top right. And in the bottom left, I have tangent of 58 degrees. And again, I just need to punch this into the calculator. So x is about what number? Let's see here. On our scientific calculator, I'm going to type in 2.7 divided by tangent of 58 degrees, and it's about 1.7 when I round to the nearest decimal place. So 1.7, and then that's all I was asked to find in this question. I was only asked to solve for x, and I have x. X is 1.7. It's always nice to come back and remember what question we were being asked. In the second example, I'm not asked to find any particular length, but rather the area, which means I need to find this length and this length because I already have my base over here. So this will complete the base if I add it to 30, and then I'll find the height as well. Let's go ahead and label that x and y for now, or maybe that'll be confusing. Maybe I'll label this h for the height, and I'll label this b for the other base. Remember, b is not entirely the base. I'll have to add it to 30 at the very end. So the first thing that I'm trying to figure out is which triangle am I looking at? Maybe I'm looking at this triangle on the right. On this triangle on the right, I'm noticing I have a variable, a number, and a variable. Is that okay? No, it's not okay because I need two numbers. I have two variables in this case. I need two numbers. So that must mean I'm using this triangle on the left-hand side. Notice I have two numbers, two constants, and one variable. That's what I'm looking for. So I'm going to redraw that triangle on the left so that I can help identify where I'm supposed to work. Right angle is here. I have a length of 30 in the bottom, a 24 angle in the bottom left, and h is up here. All right, so let's go ahead and label this triangle. On the opposite side of the angle of reference, I have my opposite, and therefore my adjacent is down here. My hypotenuse is up here, but I'm not using that. And be careful, h does not mean hypotenuse here. I just made it as a variable name. Maybe I should have chosen x or y. So from here, what trig function relates O and A? It makes the OA sound, and that is tangent because it's TOA. So it's going to be tangent of my angle of reference of 24 degrees in this case is going to be equal to my opposite over my adjacent. So my opposite is h and my adjacent is 30. From here, I need to solve. Notice that again, I can just move this 30 up here using that diagonal trick that I showed earlier. And my final answer before I punch it in the calculator is going to be 30 times tangent of 24, oh, I can't write here, of 24 degrees is equal to my height. And this is where I'm going to use my calculator again. Let's bring that back out. So I'm going to type in 30 tangent of 24 degrees, and that means my height is going to be approximated in this case. It's going to be 13 point, rounding to one decimal place, that's going to go up to 4, so 13.4. Okay, so what does that mean? That means that this length right now used to be h. I'm going to call that now 13.4. Now I have two numbers and a variable. I'm ready to use this right piece of my triangle. So let's go ahead and redraw that. I'm now going to redraw this triangle. Say I have this piece of the triangle right there. Could be to scale a little bit better, but that's okay. I have 13.4. I have 56 degrees, and I have this length b that I'm trying to figure out. So I'm going to label my triangle, opposite of my angle, adjacent to the angle. The hypotenuse I'm not going to use, so I'm going to go ahead and leave that blank. So again, I'm going to be using my tangent function because tangent makes the OA sound, the TOA from SOHCAHTOA. So not maybe the best example because I'm using tangent twice, but it's okay. So I'm going to say tangent of my angle of my 56 degrees is going to be equal to my opposite divided by my adjacent. So my opposite is b in this case, my variable, and my adjacent is 13.4. From here, you're going to solve exactly the same way that you did the last time. This 13.4 is going to come live up here next to the tangent, and this is going to now say 13.4 times tangent of 56 degrees is going to be equal to b. So I'm going to approximate b to one decimal place, pull my calculator back up, and I'm going to type in 13.4 times tangent of 56 degrees, and that's going to be approximated as 19.9 when I round it to one decimal place. So from here, I'm going to leave my calculator because I know I'm about to use that. I need to solve this thing. I need to find the area of the triangle. Remember, I'm asked to find what is the area. The area is the entire base times the entire height, then divided by 2. So the entire base down here is 30 plus b, when we just figured out b. B is 19.9. So what is the base? If you don't know, you can use a calculator. It's going to be 30 plus that 19.9. So 49.9 is our entire base. So we can say, I'm going to write here in pen, that our base is equal to 49.9. Our height is equal to 13.4, and I'm ready to plug this into the calculator. So I have area is equal to base times height divided by 2. My base is 49.9 times the height of 13.4, and that's all going to be divided by 2. So calculator, here we go. So I'm going to set up my fraction. On the top of my fraction, I have 49.4. 0.9, I apologize, 0.9 times 13.4, and on the bottom part of my fraction, I have 2. And this is going to turn into, and again, I need to round this, so whenever I round, I do this approximately equal to, then 334.3. And there's my final answer. All right, that concludes the notes for lesson 8-4, multi-step trigonometry. Thanks for watching.